my fellow assassins, to another episode of the Dark Assassins Podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Before we get started, I want to just take a quick moment at the top of the episode here to wish all the moms out there a very happy Mother's Day. If I know this is coming out on Saturday, but let this be a reminder for all of you out there to make sure you wish your moms a happy Mother's Day tomorrow. Or if you're listening to this after Mother's Day, let this, I guess, be a reminder if you forgot to wish your mom a happy Mother's Day, to go ahead and do that. But with that out of the way, let's get into this week's trivia question. So this week's trivia question is, who created Git? So all of us software developers know Git, the amazing source control system. Who was the one that created it? And bonus points if you can give me the year in which it was created. So that is the trivia question for the week. Now, on the topic of cybersecurity, I had a memory, I guess, come back to me this week, and I thought I would talk about it, which I find kind of interesting. So this is a story about how I managed to hack an iCloud account with Windows XP and AOL Desktop. Now, while Windows XP might make it sound like this was from a long time ago, I believe, I actually don't remember the year, but I want to say it was like around 2017-ish, because AOL Desktop was still a thing at this point, but it was in the phases of being deprecated, end of life, no longer supported, that kind of a thing, which I think was like around 2017 time frame. So it was somewhere in that neighborhood. So that's some context. So basically what happened was my grandmother had some problems with her iPad. And I don't remember exactly the problem she was having, but it was essentially a problem with her iCloud account, and she couldn't sign in to it because she forgot her password. And she didn't have it written down anywhere, so she couldn't log in, that kind of a thing. So they tried to take it to the Apple Store, and because she didn't know the password, the geniuses at the app, and I'm not using that like as a sarcastic way, if you're aware, the people at Apple that like work on like products and stuff and like repair things, they're actually called geniuses. So I'm not doing this as like they're idiots type of a thing. So the people at Apple, they didn't really want anything to do with it because they, just out of the abundance of caution that perhaps this iPad was stolen because she didn't know the password. And I think she might also not have had the receipt for it too, since I think it was like a gift. So, I mean, no receipt, don't know the password. I mean, if you're in retail, that is kind of a red flag for a device. So, like, I guess it's understandable. So anyway, she couldn't figure out the password, and I had an idea, because if you never used AOL Desktop, basically what it allowed you to do was allowed you to like more or less auto sign in to like select email accounts. So I had this idea: what if we take her old computer with Windows XP that also has AOL Desktop on it and try to see if we can't get into the email account? Because if we can get into the email account, then we can do a I forgot my password thing to get Apple to send us a link to reset the password. So that's what we tried to do. So we brought her computer home with us from visiting her, and we plugged it in. Sure enough, AOL Desktop was still there, and it hadn't been discontinued yet. It still worked. So we tried to see if we could get on the email account. We could. So we got into the email that we needed to get into. So we're already hacking. We broke into the Windows XP machine. We broke into the email account. We're almost there. We got the forgot password, here's the link to set up a new password email. We got that. So we were another step along the way. But here's where we ran into a minor snag. The snag we ran into was Windows XP, obviously, was pretty old at this time. And browser support for Windows XP didn't really exist at this point. So we weren't able to actually access the link. So that's where the story ends. Bummer. All right, moving. Just kidding. That's not where the story ends. It continues. So since we have this email, what we did was we forwarded the email to one of, I don't remember if it was like my account or my dad's account, someone's account. We forwarded the email, and then we logged into our email account, and now we have the email that's supposed to be going to my grandma's email account because we forwarded it. We open up the email, reset the password, and bingo bango, we hacked my grandmother's iCloud account. Yep. So that, I guess, in the sense is like hacking for the good, or I guess ethical hacking, or white hat, or however you want to define it. The reason we went out on this hacking expedition was to recover an account for a family member. And obviously we had her permission to do this, so it's not like we were, doing this maliciously or anything like that. But I thought that was just a fun story, that we were able to hack a iCloud account with ancient technology at the time, that being Windows XP and AOL Desktop. And thankfully, AOL Desktop was still supported at that time, because I think it only had a few months left before it was going to be going the way of the dinosaurs. And the reason why that was so key was because we obviously didn't know the email password, but because it was already signed into AOL Desktop, we didn't need it. So I guess going back to a cybersecurity tip from a while ago, the whole thing about signing out of your accounts when you're done with them, so your grandchildren can't break into your email account. But in all honesty, though, if that didn't happen, then we would have been in a lot worse situation for her. So fun story that I thought I would share. And with that cybersecurity-ness, let's get into this week's cybersecurity tip. So for this week's cybersecurity tip, we talked about in the past about securing virtual ports, like securing ports on your firewall, whether that's your router's firewall, you have a dedicated firewall, or even the firewall on your actual system. Now, there's another way that you can secure ports also, and that is securing the physical ports on a device. Now, some machines will have this as an option in the BIOS, where you can essentially disable USB ports on the device. So as a way to maximize physical security, you can also disable those ports as well, because obviously a common way to inject malware easily without having to do a remote attack is just plugging a USB stick in. And we talked about a few episodes ago about why you don't want to plug in random USBs that you find lying around, because they can be malicious. So if you have all your USB ports disabled and someone tries to plug in a malicious USB into your computer, nothing's going to happen because it's disabled. So you have nothing to worry about. Now, I hear you saying, if I disable all the USB ports, how am I going to use my computer? And you have a really good point, because you can't. Well, you kind of sort of can. But it's complicated. So basically, if at least on the couple Dell machines that I looked at, you can, if you disable all the USB ports, they're only disabled when you're booted into the OS. So basically meaning that if you have all the USB ports disabled, you can still plug in a USB keyboard and then get into the BIOS and mess around and change stuff if you need to. So theoretically, you could have this machine, in another room, in the same room as you, or, who knows, it could be wherever. And then you basically just have it running more or less as a server, essentially, that you can just remote desktop in, or you could remote shell in, like with SSH, or some way to remotely control the system. Because if you're remotely controlling the system, realistically, you don't really need the USB ports anyway. Now, generally, this is probably more common on something you'll see on like dedicated servers. For example, my R620 and I believe my R510 also have this ability where you can disable the USB ports as well. But those are a little bit different. They're obviously a different use case, right? Because those are going to be rack-mounted systems off in a server closet or off in a data center somewhere where no one's realistically ever going to touch them. And in that sense, you really don't need the USB ports at all. One, because realistically no one should be using the USB ports anyway, so you might as well disable them if no one's going to be using them, because, back to one of the key fundamentals of cybersecurity, principle of least privilege. So if you don't need the USB ports, just disable them. If you don't need access to admin privileges, don't have them. That kind of a thing. But the other thing with these rack-mounted servers is they have, IPMI, lights out management. In this specific case, Dell servers, they have iDRAC, which is Dell's solution. And what this allows you to do, as we've talked about before, is you can get a remote console of the actual system. So you can plug in any USB drives you need remotely, and control the system remotely, so you don't even need physical access to the system, in which case you really don't need access to the USB ports. And if you did need access to the USB ports, well, you could easily just shut the machine down. You'd have access through the IPMI, you go into the BIOS, change the setting, re-enable them, and then you're good to go. So that is part of the reason why you might potentially want to disable the USB ports for greater physical security of your system, because you can harden the networking and the software on a system all you want, but if someone gets physical access to the system, they can kind of do whatever they want, to an extent, depending on how software-wise you have the system locked down. But if they can easily just plug in like a USB and just do whatever they want, then that's an issue. So this is just another layer of Swiss cheese, if you will, that you can add on to your layers of security to really harden a system. Now, I did mention that just because you disable all the USB ports, you still have access to plug a USB cable or a USB keyboard in and access the BIOS. So obviously that's not going to really do you much good if an attacker can just waltz up to the system, plug in a keyboard, realize it doesn't work, powers down the system, boots it back up, goes into the BIOS, and changes the settings. So obviously that's part of the flaw. That's the Swiss cheese, right? There's a hole in the cheese, but it blocks other things. Now, another layer you could put on top of that layer of Swiss cheese would be to add like BIOS passwords, for example. So to like even harden the BIOS to make it even harder for someone without the knowledge of the password to get in and modify things in the BIOS. So these are just, more layers of Swiss cheese that you could put on to your security. Now, granted, in a home environment, obviously, if it's like just you, this probably really isn't even an issue, disabling the USB ports, and it's honestly probably more of an inconvenience than it's worth. But at the end of the day, when we talk about cybersecurity, it's always that battle between convenience and security. Generally, the more convenient something is, the less secure it is. Obviously, if you can't have any USB port access to a system, you're going to be a lot more secure than if you can. But on the other side of that, not having USB access can be pretty inconvenient at times. But then again, like if you're in like a business environment, or you have roommates or something like that, and people that you might not necessarily trust with the systems, or the systems are just unattended and someone could potentially waltz in and mess with it, that would definitely be an instance where you might want to lock down those ports. But that's for USB ports. Other ports that exist, going back to networking, are ports on a switch. Now, if you have a dumb switch or an unmanaged switch, you don't really have any control over this. But if you have a managed switch, what you can do is you can actually disable all the ports that aren't being used. So if, say, you have a 48 port switch and you're only using 16 of those, because if you have a switch, you obviously can't use all of them, and you have to have like 15 switches, all 48 ports each, and only use like 5 ports on each switch, because that's how you do it. But joking aside, if you have, say a switch and you have unused ports, it's generally good practice, especially in enterprise and business environments, to disable all ports that aren't being used. And the reason for this is if someone gets physical access to the switch, they could easily just plug in a device into that switch and have free reign over your network, which you obviously don't want happening. Now, just because you disable the port doesn't mean they can still get in, because you're probably thinking to yourself, well, yeah, but I mean, if you disable all the ports, they could just unplug one of the devices that's already plugged in and plug their device in, which you're absolutely right. They can do that. But another thing you can do on managed switches is you can tie specific MAC addresses to specific ports on the switch. And what this will do is if a new device plugs into a port and their MAC address is different than the MAC address associated with that port, it'll block all the traffic and they won't have access. So that's another thing that you can do to harden your switches. But again, this goes back to that convenience versus security. Obviously, it's kind of inconvenient if you have to swap out a system or something, and then you have to go into the switch and change the MAC addresses of all of the ports potentially that new system is replacing, all the new ports it's plugged into. So there's obviously a decent amount of configuring that has to go on. But at the same time, it's a lot more secure, because you can't really... Realistically, no one's going to be able to unplug a device, plug theirs in, and take down your network. Now, obviously, if they knew, say, the MAC address of device on port 13, and they spoofed the MAC address of their system to be the same one as that device plugged into port 13, then, yeah, I mean, there's nothing you can really do about that. But the level of knowledge and skill and insider knowledge of the infrastructure to be able to pull something like that off, I mean, obviously it's kind of low. Not your average Joe isn't obviously going to be able to do something, pull off an attack like that. But then again, it's just these extra layers of Swiss cheese, right? You disable the ports that aren't being used on the switch, and you tie all the ports that are being used to a specific MAC address. Is it foolproof? No, but it's definitely much better than having all the ports enabled and any device that plugs into it has instant access. So yeah, check your ports, both on your switches, your devices, and obviously on your firewalls. So that is your cybersecurity tip for the week. Now, a bit of quick news bites before we get into the real juicy stuff, which is the nerdy stuff I did, but more specifically, ways that you can improve your C++ class optimization. So the news topics that I wanted to hit on real quick is Apple finally is bringing Final Cut Pro and Logic Pro to the iPad. Now, this has been something that's been rumored and wished for at least a few years now. I vividly remember, I guess it was last year or whenever, I guess maybe 2 years ago, whenever they brought the M1 chip to the iPad, everyone was saying this is going to be the time. They're finally going to bring Logic Pro and Final Cut Pro to the iPad because it has the same chip in it as the Mac desktops do. And then that kind of came and went, and then WWDC last year came around, and everyone was like, oh, this is going to be it. They're going to announce Final Cut and Logic Pro for the iPads. It's going to happen at WWDC this year. And then, of course, it didn't. But they're finally doing it now. I'm a little bit surprised they didn't announce it at DubDub. Although, with all the things that are supposedly rumored to come out at DubDub, that would kind of be a lot to throw in Final Cut Pro and Logic Pro coming to the iPad in that mix as well. Now, that's not to say they still won't touch on it. They might, but it is what it is. Now, so to be able to run Final Cut Pro and Logic Pro on the iPad, you need at least iPadOS 16.4 or later. And if you want to use Final Cut, you need an M1 chip in your iPad or newer. And if you want to use Logic Pro, you need an A12 Bionic or newer. Now, the thing that I really don't like about this announcement is it's a subscription. So you don't actually own the app, you're just renting the app from Apple. Kind of like the Adobe Suite. You don't actually own the Adobe Suite because it's a subscription-based thing, which is interesting because the Final Cut Pro and Logic Pro apps for the Mac desktop are just one-time purchases. But then again, everyone knows that the cash cow is subscriptions. And that's where people really rake in the cash, is in subscriptions. So it's $4.99 a month and $49 for the year if you just want to pay it all once a year rather than every month. I do believe also you can get like a 1 month free trial of that too if you do want to try it out. But yeah, it's obviously, I don't have an iPad. Well, actually, I do have an iPad, but it's a super old and slow iPad. I think it's the first gen iPad mini, and the only reason I got it was because it's like the slate black or whatever the black version is, because I thought it looked cool. But it is basically unusable for a couple reasons. One, it's running like it's running iOS like 9.3.5, I think, which is an absolutely horrendous version of iOS. It is so darn slow and so bad. So it's basically unusable. I basically just have it for the looks. But then again, I guess you could argue because it looks so cool, it actually makes the performance of it a little bit better. So I guess that it does have that going for it. But yeah, it is kind of a bummer that they are making this a subscription. Although I have to say I can't say that I'm too surprised by that. The other bit of news that I'm going to touch on real quick here is so everyone's, based on market share anyway, everyone's favorite search engine launched their own foldable phone. So Google came out and launched the Google Pixel Fold. So they launched their own version of a folding phone. And to be honest, I'm not an Android guy, but the looks of this thing actually aren't too bad. Like, it's actually a decently looking phone. Of course, like all folding phones, it has that crease in the middle of the screen when you unfold it, which personally I don't think looks that good. But aside from that, I think it looks pretty decent. But the one of the main things about it is it's thinner than most folding phones because it takes a slightly different approach than other folding phones. The main thing is the mechanism for like the hinge and how it folds. They made the bezel a bit thicker to accommodate for basically where the folding mechanism is, rather than like behind the screen. So it allowed them to make the screen, or I guess the overall thickness of the phone, a little bit thinner, which I think is pretty nice. Obviously, I'm not going to get one, as we'll soon see with the price, but it is what it is. It is 120 hertz refresh rate, which is very nice to see. Apple could definitely learn a thing or two with its base model iPhone, still running at 60 hertz. Yeah. One other thing that is kind of interesting, though, is it has a 4,800 milliamp hour battery, which, for context, the Pixel 7 Pro has a 5,000 milliamp hour battery. And the Pixel 7 Pro only has one screen, where the Pixel Fold has one screen on the front and then folds open to have another bigger screen in the middle. So it's driving more screen and has a smaller battery. So, not sure what that's going to mean for battery life, but I guess people who buy it will see. Now, it obviously has the early foldable phone adopter tax because it comes in at a whopping $1,800. So if you got that much money burning a hole in your wallet and you want to buy a Google Pixel Fold, knock yourself out. I will not be. But, I figured I would cover that, since we cover a lot of Apple stuff on here from time to time, but figured I'd mix it up a little bit and cover some other stuff as well. So with that, let's get into what nerdy stuff have I been up to this week. So if you listen to the conversation I had with DOS Dude 1, which if you haven't, I highly recommend you go listen to that. Part of that conversation that we had was talking about Open Core Legacy Patcher and some of the issues that I personally have had with getting my Mac Pro up to Ventura. Well, boy oh boy, third time's a charm. My Mac Pro is finally running Ventura. Everything is working like it's supposed to be, and it's all good. And it's about time. The funny thing is, the past two times when I tried to install Ventura, I was like, oh, I don't need a Time Machine backup, and then I actually ended up having to wipe my drive and reinstall macOS Monterey. Well, this time I actually had the forethought, because I actually took my own advice for once and made a Time Machine backup. And then, of course, the one time I do make the Time Machine backup, I don't actually end up needing it. But then again, better to be safe than sorry, and I'm honestly just glad that it's working. So that was definitely a big win this week. And also, another win this week is, do you guys remember... I'm sure you do, since I've mentioned it on a couple occasions, the Red Hat Infinite Money glitch that I've been calling it, where you can essentially clone a single instance of Red Hat that you install, and it never increases the number of subscriptions on your Red Hat account. So when I first discovered this, when I talked about cloning it, I was only cloning it from one virtual machine on a hypervisor, and basically just cloning that virtual machine and making another one. And that didn't have any issues. But one thing I wasn't sure about is, would you be able to, say, clone this from a virtual machine to physical hardware, and would that potentially mess up things and add more subscriptions to your Red Hat account? And I don't know if I'm necessarily surprised, but it does not add additional subscriptions to your account. And I'm not sure if I've mentioned my thoughts on why this is or not, but my leading theory is because when you install Red Hat, I'm assuming they have some kind of UUID or universally unique identifier tied to that install. And when you clone the install, you clone that UUID with it. So as far as Red Hat's concerned, it's the same machine. That's my assumption. I have no idea if that's true, but that's really the only thing I can think of as to why they wouldn't pick it up as a new device with a new install. That's my leading theory anyway. But it still works, and I have to say, cloning it from a virtual machine to physical hardware, basically how I did that was I used a tool called Clonezilla, and basically what I did was I had my virtual machine be the server or the host of where to clone from, and then the physical machine I was cloning it to had that reach out to the server and then essentially download the OS basically. And I have to say, that was probably the fastest operating system, quote-unquote, install that I have ever done, because that was pretty quick once I actually figured out how to use Clonezilla and did it right. Because it did take a couple of tries. Thankfully, the OS that was on there before I didn't care about, so, I mean, it wasn't an issue. But it did take a couple of tries before I actually got it working. But once I did get it working, yeah, no issues at all. Works great. Fantastic. So the Red Hat Infinite Money glitch gets even better. And now we're going to get into back to the stuff that I teased a little bit earlier, which is the C++ class optimization. But I guess a bit before that, so I've mentioned before on the podcast that I've been trying to work on my own video game. And obviously that was on a hiatus for a while, as most personal projects tend to go on. But in addition to optimizing some of the classes and stuff, I also made it compatible with my distributed compiler, the Dynamic Cluster Compiler, which I was pretty hyped about. So I was pretty hyped to get that working. But now on to the performance aspect. So one thing that I like to talk about on the podcast is the importance of writing optimized code, efficient code, and just good code in general. And the thing is, when I set out to make this game, I wanted to write it as efficiently and as optimized as I could. And obviously, since we're having this conversation, I found a place in my code that was not optimized. And actually kind of significantly. At least at the moment, it wasn't really a huge deal because it's still in, I guess you could call, the infancy phase. But basically what I did was I reworked a good chunk of the code because it was kind of like a viral part of the code, in the sense that for those of you who have programmed, you probably know what I'm talking about, where you make one change somewhere, like say you change the name of a function, and then you have to go hunting around the code for every single instance where you call that function and rechange the name. That's basically what was going on here, but rather than a single function, it was multiple functions and like an actual full-on data structure being changed. So there was a lot of hunting around and changing things, building, getting errors, fixing errors, thinking everything built but didn't work, so fixing logic problems. It was a good few hours trying to get it to work, but it works now, and this is only part of the optimizations that I'm planning to implement. But basically, when we talk about optimization, there's a couple ways that you can optimize code for. You can optimize for speed, you can optimize for memory usage, and you can also optimize for storage, or like when you end up saving whatever progress of your, basically the save state of the program, so you can resume where you were when you run the program again. You obviously have to save that state somehow, and the way that you generally do that is writing it to a file or writing it to a database or some other kind of secondary storage. And I'm not, as far as performance goes, I can't really judge if it is any faster because it was already quick, because one, there isn't much happening, and two, it's C++, which is already one of the fastest languages out there. So can't really judge from that perspective, but from the memory usage and storage space usage, it was pretty significant when it comes to the improvement. So let's give some background here. So I don't know if I've actually talked about what game I'm trying to implement or not, since I don't remember if I mentioned it back when I started talking about this project. But basically what I'm trying to do is I am trying to write my own Pokemon game. And no, I am not making a ROM hack. I didn't download source code from anywhere. I am writing this completely from scratch. So I started with a blank Xcode project and started from there. So zero source code. The only source code or library that I'm using is a graphics library, specifically Raylib, because initially I did want to write my own graphics library, but then I looked into it and realized that would be a massive personal project in and of itself. And two, I am terrible at everything graphics, so that was basically a no-go once I did research into it. So aside from that graphics library, all the code for this project I wrote from scratch. So if you've never played Pokemon before, every Pokemon has the ability to know 4 moves at a time. So in order to represent moves, I created a class. And a class for a generic class for moves, and then child classes for each of the specific moves that are tailored to, the damage dealt, any kind of side effects of the move, the type, all that good stuff. And then obviously each Pokemon is a class that, because it can have up to 4 moves, could potentially have 4 of these move objects in it. Now, my initial plan was to have an array of 4 elements, and each one of those elements would be an object of the move class. Now, this seemed like a good idea at the time, right? Every Pokemon has 4 moves, so it makes sense to have an array of 4 elements, and each one of those elements in the array would be a move. But here's where part of the problem comes in. From the memory, I guess we'll start from the storage aspect. In order to save that single Pokemon, we've talked before about serialization. You have to serialize the object. So you have to serialize the Pokemon object. But the Pokemon object has 4 move objects. So you have to serialize each one of those move objects inside the Pokemon, so you can see the size for one Pokemon gets pretty large when it comes to saving data. And even as far as like the memory footprint, because you have one object that is the Pokemon, but it also has 4 objects inside of it, along with all the other data it has in it. So that's a lot of memory. And especially when you're talking about a Pokemon game, you're scaling this to the however many hundreds of Pokemon I ended up putting in this game, it might not seem that much if you only have, say, an extra, to be specific here, I actually ran the numbers. As of the recording of this podcast, a single move object counts for 88 bytes of data. Now, 88 bytes doesn't sound like much at all, but you have to remember that you have to multiply that by 4, and then you have to multiply that by as many Pokemon that are in the game. So that adds up pretty quickly when it comes to memory usage. Now, normal game developers might be like, meh, who cares? Modern PCs got tons of memory anyway, who cares? But I want to be as optimized as possible. So I thought, how can I make this better? And I had a thought. And initially when I was designing the game, I had already created a static global instance of every single possible move that I'm going to have in the game, so that way I can do lookups for other things that I might need. And I thought to myself, okay, if I already have this global object that contains every single move, why do I even need to have each Pokemon have an instance of that move when it already exists somewhere else? Because in this sense, I'm just adding more memory for literally zero purpose, because that move already exists in memory. So there's no need for me to allocate more memory for something that already exists that I can reference. So basically what my solution was rather than have 4 objects of this class, I can just have 4 integers, which, if you're not aware, an integer is 4 bytes. So 4 integers, that's 16 bytes, that's a fraction for all the moves a Pokemon can know compared to just one move of the move object, which was 88 bytes. So you go from 88 times 4, which is 352, down to 16. And then obviously you scale that to as many Pokemon that are going to exist, and that's a pretty large savings when it comes to memory. Not to mention the fact when you're serializing this data, now all you have to do is write a single number to the file in this place of a move, rather than an entire move object. So you significantly reduce the memory footprint, and you significantly reduce the storage space on the disk that you're taking up. So major wins just by one tiny optimization in changing the fact that I'm using 4 move objects and now I'm using 4 integers. Now, how can I get away with using 4 integers to represent 4 moves? And the way that this works is actually kind of simple and ingenious, I think. Not to brag or anything. But basically, so this is how it works. Every move has an ID associated to it. So basically what I do is I take the ID of the move that is the Pokemon knows and add it to the integer. But how do I add multiple things to the integer and keep everything straight? Because that's the main challenge here. And if you have used a lot of C and C++ and some low-level manipulations of things, you might be able to see where I'm going with this. But the reason why I'm able to get away with an integer is because when it comes to the moves that a Pokemon knows, we only really need to keep track of 2 things. Because there's really only 2 things that make, say, the move Tackle significant from, say, a Zigzagoon versus a Pikachu, right? And the only difference is how much PP does that move currently have, and what's the most amount of PP that move can actually have. So you only have to keep track of that, and then obviously you need to know what move it is, so then you add the ID on there. So that's 3 values that we need to know for the given move. Everything else we can just pull dynamically from the move on the fly whenever we need it. So here's how we do this. So the first step is we take the ID of the move and then we do what's called a bit shift of the integer. So we shift the ID of the move 16. So basically what that means is if you think of a number, it has different places, right? It has the ones place, the tens place, the hundreds place, etc. But obviously we're not working in decimal. We're going to be working in binary. So we shift over 16 bits, and then we place the number of the ID of the move there. And then what we can do is we can OR that value doing an OR operation. So if you're not familiar with how an OR operation works, you take one number, and if you go digit by digit, and if that value is a 1, whether one of them is a 1 or both of them are a 1, you have a 1 as your result. So basically what this allows us to do is combine two numbers that have different numbers in places. So that was a horrible explanation, so let me try to explain it this way. So pretend that you have a 4-digit binary number. Say you have 1100. That's your first number. And you want to OR that number with 0011. So the result of that operation would be 1111, or 4 ones. And the reason why that works is because you take the 1 of the first number and the 0 of the second number, and you check, is either one of these a 1? It's yes, one of the first number is a 1 in the first digit, so we have a result of 1. Then we go to the next place, and we see that again we have a 1 and a 0. And if either one of them is a 1, then we have a resulting 1. And then we do that for the remaining 2, and we get the 1. So that's how we can OR the values together and not mess up what we already have stored in the integer. And then we also shift that value for the PP over 8 bits. So then we have in the first, the upper bits of this integer, we have the ID of the move. And then from 8 bits to 16 bits, we have the PP of the move. And then the lower 8 bits is the total PP of the move. So then basically what this allows us to do is we can easily pull the ID of the move by just checking what the upper 16 bits of the number are, and there's the ID of the move. We want to get how much PP is left of the move. All right, we shift over 8 bits and read 8 bits there, and that's our PP, how much PP we have left. Okay, well, now we need to restore the PP. How much are we able to restore to? Well, we take the first 8 bits of the number, and that's the total PP that we have. So by doing these bitwise operations, we can deal with all the data we need, and then if we actually need to use the move, like say we're in a battle or something, we can just go to that global dictionary object where it has all the moves, and because we have the ID already, we can just plug that in, and we get all the data about the move that we need. So we take this from having 4 move objects down to 4 integers, because we can do some fancy computer science math trickery to optimize the code for memory and optimize for storage space. Now, as far as the storage space, it's kind of hard to tell how much I actually saved, but I did notice a significant decrease. Now, I am doing compression on my saved object, so it's a little bit deceiving from the result, but I believe before the compression started, the testing I was doing had, I want to say it was 3 Pokemon was being saved, I think. So before I switched over to having 4 integers rather than 4 moves, when it was 4 moves, I want to say it was somewhere in the 4,000 bytes range with the other stuff I was saving, and then literally just changing the moves to save as 4 integer values, drop that down from over 4,000 to like around 1,000. And that was just for 3 Pokemon with a minor change of going to an integer. So, this is the thing when it comes to optimization, right? If you've never tried to like optimize anything, the crazy thing that I've found in all the various work I've done with optimizing things, both for performance and for memory and storage, is something so minor and something that might seem so insignificant, like specifically at a smaller scale. Once you scale that up to something larger, it makes a huge difference. Now, let's go back specifically to the memory footprint. So when it comes to the memory footprint, I actually kind of ran some numbers on this because I was kind of interested about it, and it was pretty easy to do. So I mentioned that the move class as it exists right now takes up 88 bytes each. And when you shrink that down to an integer, as we're doing here, an integer is 4 bytes. It takes up 4 bytes of memory. So you go from 88 to 4. Now, obviously, you have to multiply that by 4 because each Pokemon has 4 moves. So you multiply the 88 bytes by 4, which is 352 bytes, compared to 4 integers, which is 4 bytes times 4, which is 16 bytes. So even there, that's a pretty large difference. But then again, we're just talking about bytes. Computers have gigabytes of memory, so that's basically a drop in the bucket. That's nothing, especially on modern hardware. But let's but at scale, when this game's actually done, it's going to have hundreds of these objects, right? It's going to have hundreds of these Pokemon, one just in the array of like the Pokedex, right? That I'm going to make. Obviously, I'm going to need an existence of one of each kind so I can reference it. So you have that large number, and then you'd also have the large number of however many Pokemon that exist currently in memory, say you're in a battle or something, but also exist in, say, the player's box and their party. There's going to be a lot of Pokemon here, right? So just for some numbers, if you have, say, 250 Pokemon, which realistically this game's probably going to have more than that, but just for this argument here, for this example, so 250, and then you multiply that by the 352, which is the number of bytes that would be occupied if I used 4 move objects. So that's 250 Pokemon times 352 would be an additional roughly 86 kilobytes of extra data just for the moves. 86 kilobytes, which again, modern computers, that's a drop in the bucket, right? But this is the crazy thing. It's 86 kilobytes for moves when you use the full-on move object, but then when you convert that to the 4 integers for a move rather than the 4 move objects, the 4 integers multiplied by 250 is less than 4 kilobytes. So from 86 kilobytes for 256 Pokemon just for the moves, down to 4 kilobytes for 250 Pokemon just for the moves. That is a reduction of 22 times. We're using 22 times less memory, which is absolutely insane. Right? Like, that is a massive reduction. And then you even potentially have even more Pokemon than that. The difference just grows even more. So, and then that's not even mentioning when it comes to serializing all this data. I mean, I already mentioned going from like around 4,000 to like 1,000 just for 3 Pokemon. You scale that up. Oh boy. So, yeah. So when it comes to your C++ programming, if you're working with classes and stuff, and you're basically only using your classes as reference objects for other things, and you have multiple instances of the same class. If you can figure out what's going to be different from each one of those classes, you can then take a smaller object, whether that's an integer or a smaller struct or something, and greatly reduce the memory footprint and potentially saved data footprint of your program just by then having all of the instances of your class as, say, some kind of shared object that you can reference, obviously assuming that you're going to be using all of them. Obviously, if you have specific use cases for each class, this isn't really going to help you that much, because if you say always have unique instances of like 5 classes, there's really no sense in having a list of 20 classes in some like global array or something that you can reference if you're only really going to be using 5 at a given time, and they're all distinctively unique from their base form. But obviously in this specific use case, they're never going to be different from their base form, aside from the things we mentioned, basically the PP values. So that's really all we need to keep track of, and we can just throw that in an integer and we're good to go. So as far as other optimizations go, I am planning on essentially optimizing the Pokemon class, because right now it has a bunch of different stuff in there that's required for the Pokemon, but when it actually comes to managing a Pokemon that already exists rather than creating a brand new one, you don't need nearly as much info on that, because you can easily just pull from those global objects that already exist. You don't really need to have that for every single one, so you can just easily reference it and recalculate stuff. So that's gonna kind of be my next thing. But yeah, this week was pretty much rewriting the entire, well, not the entire game, but a decent chunk of the core of the game. Like, obviously a Pokemon is a kind of a core feature, I would say. And I'm only going to continue to rewrite it and re-optimize it. But man, I gotta say, if you get into trying to optimize stuff in your programming and your code projects, it is one heck of a black hole. Because you find an optimization, you implement it, and you're happy, and then you're like, wait a second, I could probably optimize this more, and then it's... You gotta kind of watch yourself, because another optimization, this is just a quick thing to wrap up here. Another thing I optimized for was I wrote a program to find prime factors of a given number. So basically you would input a number that was the prime factors of, or the product of 2 primes. So for example, you give me 77, that's the product of 7 and 11, which are both prime numbers, and the program would find those prime factors. And man, the amount of time that I sunk into optimizing that algorithm, testing it, running it, thinking of something else, changing it, which ended up optimizing it even more, and then thinking of something else, changing it, and just continuing to optimize the living heck out of that thing. I sunk many hours into optimizing that program, and I got it pretty darn optimized, I gotta say. Obviously the first optimization I did was like a complete rework of the algorithm, which was a night and day difference. And then everything after that was kind of like incremental chunks. But basically what it ended up doing was it ended up taking a number that was around 2 to the 64 power. So basically the max that a uint 64 could be if we're talking C++ land, which is like 18, I forget how many zeros, but 2 to the 64, so very large number. It could find the prime factors of that, not specifically 2 to the 64, but a number around 2 to the 64 that is the product of 2 prime factors. It could, when I first made the optimization from my first go, completely rewriting the algorithm, it was like 10 seconds-ish. I think it was like 9 point something was what I was clocking it at. And then I did some optimizations to it and then dropped it down to like 3 seconds for that same number, and then did some more optimizations and dropped it down to like less than 2 seconds. So, I mean, it was just like a constant, like, where can I shave time off? Where can I improve this? Where can I optimize this? How can I reduce the O of N space, I guess you could say, the search area, that kind of a thing. So definitely if you're going to look to optimize your code, be careful, because it is one heck of a drug. It is very addictive. But I mean, I think all programming personal projects kind of are that way. Once you kind of get on a roll with them, it is very hard to stop them. It's very hard to get up and just say, okay, I need to take a break from this. Because if you don't tell yourself I need to take a break from this, you can easily go hours and hours and hours just sitting at your computer, click-clacking away, and being an absolute code monkey like I was this week. But I think that's probably going to do it for this week's episode. But of course, before we go, we have to get to that trivia question. So this week's trivia question, if you recall, is who created Git? Specifically, Git, the source control program. Not to be confused with GitHub, GitLab, Git or any of those types of things. The Git you install on your computer, that Git. Who created it? Now, if you said Linus Torvalds, aka the guy who wrote Linux, you are correct. And the bonus points for if you said 2005 for the year that it was created. So congrats to all of you who got this week's trivia question correct. For all the moms out there, I'll give you the free points anyway, even if you didn't get it right, because it is Mother's Day. So congratulations to all you moms out there again. And if you enjoyed this episode, I ask that you leave it a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already. Also, be sure to share with a friend or family member who might be interested in learning about some of these C++ class optimization tips, I guess, if you can call them that. And if you have any questions about this episode, or you have any questions for future episodes, feel free to shoot me an email at contact@darkassassinsinc.com, or you can click the link down in the show notes below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.